Good evening, everyone. Myself Arnav Ganguly, going to take the class of power electronics. Today's topic is the different quadrant operations of chopper circuit. Now, previously we already discussed about the function of chopper and the classifications part like step up chopper, step down chopper, and the working principle of the chopper circuits is already we have discussed. Now there is another part of chopper, that is the quadrant operations of chopper circuit. Now based on that we can classify the chopper circuits in 5 modes, that is type A chopper, type B chopper, type C chopper, type D chopper, and type E chopper. Now individually we will discuss the principles of choppers. Now firstly we have to discuss about type A chopper. See the basic circuit diagram of the type A chopper. Now this is a freewheeling diode, that is FD, and this is the chopper switch, that means the semiconductor switch is connected here, that is working like a chopper, acts like a chopper, and here this is the load parts. Now firstly see, when the chopper circuit is going to conducting mode, that means this switch is now in on conditions. Now when that is in conducting mode, the current is flowing through the chopper circuit to the load in these directions. So this current is considering here as I0 current. Now then the value of voltages through the load towards the load is going to be V0 equal to Vs, because the total source voltage is now going to feed the load. So now that is V0 equal to Vs, and current is flowing from source to load, that is from Vs to load the current I0 is flowing. That means if we considering about the quadrant, then we can say that there are 4 quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Now in this cycle the V0 and I0, the total values is in the first quadrant, because that is in positive part, that is in positive value. Now when this chopper is going to be non-conducting mode, then what will happen? See, the chopper is going to be non-conducting mode, means the source voltage is now cannot feed the load, but here the current is going to be discharged through this freewheeling diode and load. That means again we can say that when the chopper is in non-conducting mode, then the voltage across the load V0 will be 0, but the current is flowing in the same direction, that means in the positive side. So we can say that the total operations of the type A chopper, that is belongs to the first quadrant mode, because V0 and I0, the total, the values, the magnitudes is in the positive directions, the magnitudes is the directions is in positive side, that means this is a in first quadrant, so that is we draw in first quadrant. Now this type of type A chopper, this is actually we can consider it as a step down chopper. Now when we are going to considering about type B chopper, then we can see that the type B chopper is actually behaving like a step up chopper. How? See, this is the basic diagram of type B chopper. Now here this is a voltage source Vs, this is the chopper circuit, this is a diode, this is a inductance, and this is a EMF source. Now when this chopper is in conducting mode, then what will happen? That means from this voltage source a current is flowing through the chopper and load circuit. So in this region there is no voltage across the load, but the inductor actually going to store the energy, because we know that when the current is flowing through the inductor, then we can get a EMF and inductor can store the energy. So we know that VL, that means the voltage across inductor, equal to L di by dt. Now when the chopper is going to be non-conducting mode, that means this is in off conditions. So when that is in off conditions, then what will happen? This current cannot go through this chopper, so the current is now going through the EMF source to the source side. That means from the load side to the source side the current is going to flow. That means the directions of current, that is going to be a negative directional, because when in the first cycle chopper is in conducting mode, then the current is flowing through these directions. This is the directions of I0 then. But now the chopper is in non-conducting mode, so this current actually now going to be discharged through this side. That means the load side is going to feed to the source side, so this I0 is now going to flow in the opposite directions. That means now in the non-conducting mode of this chopper, the total voltage across this path, that is going to be E plus L di dt. So E plus L di dt, this is obviously now the voltage of this part, and that is obviously more than the source voltage Vs, because this stored energy is now going to feed from the load side to the source side, because we know that the current is always flowing through the higher potential side to the lower potential side. No, now this terminal is acting like a higher potential side, because that E plus L di dt, this is now the voltage of this part, and that is more than the source voltage. So the current is going to flow from load side to the source side. That means power is feedback from load to source. So it is called as a step up chopper. Why step up chopper? Because the output voltage is now more than the input voltage, so it is called as step up chopper. Now see the quadrant operation. When we are considering the quadrant operation here, see, for the both operations of conducting and non-conducting state of chopper, the voltage V0 is obviously a positive value. But when we are considering the current, then the current is going to flow from load to source. That means it is in negative directions. So it is treated like negative. So from this diagram we can say that here this is a second quadrant operation, because the voltage is positive but the current can be in the reverse direction. So it is called as second quadrant chopper or type B chopper. Now we will move to the third circuits, that is called as type C chopper or two quadrant type A chopper. So what is this? See, we already considering about type A chopper and type B chopper, that means step up chopper and step down chopper. So now by combining these two circuits we do a common circuit, that is here two choppers are there, CH1 is chopper 1, CH2 is chopper 2, and that is a freewheeling diode FD, that is a normal diode D2, this is the inductance, and now this is the EMF source. Now what will happen? See, here always the voltage across the load obviously will be positive because there is a freewheeling diode. Now if we consider that in this circuit that CH2 and FD, or CH2 or FD is in conducting mode, then the value of V0 will be 0. And if suppose we are considering CH1, that means chopper 1, or diode 2, it is in conducting mode, then the V0 will be Vs. See, when CH1 is going to be in conducting mode, that means this switch is going to be closed. This is the closed path. So the total source voltage is fed to the load. That means V0 is then going to be Vs. But when this circuit is on, this is not operated, this is on, that means CH2 on. So then what will happen? The source voltage cannot fade in the load side. So then the V0 value is 0. But when we are considering about the directions of the current, then we can see that in 2 cycles the current directions will be reversed. When we are considering about the first cycle, then what will happen? Suppose this is the first cycle. Here what will happen? Suppose CH1 or FD, that is in conducting mode. So when CH1 or FD in conducting mode, suppose CH1 is in conducting mode. So what is happening? So this I current from the source side, that is coming from these through CH1 and that is flowing through the load. So this is the direction of current I, that is treated as positive current because that is coming from the source. Or if we consider that freewheeling diode is in conducting mode, then what will happen? Then from this side the current is flowing from this part and through the load. So that means this current, if CH1 or FD is in conducting mode, the current direction through the load is in same directional. Here the current is flowing through that, here the current is flowing through that. So that means the directions is same for the both case. But in the opposite part, when CH2 or D2 will be in conducting mode, what will happen? Suppose D2 will conducting mode. So if D2 will conducting mode and others are in non-operated mode, then what will happen? From this battery the current is flowing through this part to the source. That means current is going through the load to the source. That means the directions of current, obviously that will be treated as a negative current because this current is now flowing through the conducting D2 from load to source. That means we know that in convention the current is actually flowing from source side to load side. But when in these circuits the D2 will be in conducting mode, the current is going through load to source side. That means the direction of current will be changed. Again, if we considering that only the CH2 is, that means the chopper 2 is in conducting mode. So if only chopper 2 is in conducting mode, then again you can see that from this side the current is flowing through load to chopper 2. That means again the current direction will be in from load side to the chopper side. That means the current is here treated as negative. In this circuit there are 2 cycles. In first cycles, suppose if CH1 and FD is operated, then CH1 or FD operation state, then the current is flowing through source to load side. That means that is as a positive direction. And when D2 and CH2 or D2 or CH2 is in operating mode, then the current direction is from load side to source side. So that means the current is maybe positive direction, or in the next cycle it may be in negative direction. So when we are considering about the quadrant operations, here that is a 2 quadrant operations. In 1 quadrant operation, first quadrant, that is a CH1 and FD. That CH1 and FD, actually this is operated like a type A chopper, and when we are considering about CH2 and D2, it is behaving like a type B chopper. That means we already know that in type B chopper, that is acting like a step up chopper because the current is flowing through the load side to source side. So CH2 and D2, when we are considering, then the current directions is considered as negative because that is flowing from load to the source side. And when we are considering CH1 and FD, that is behaving like a type A chopper. That means the current directions is in positive side. So this is called as two quadrant chopper operations. Now our next part is, that is type D chopper. So when we are considering type D chopper, this is another two quadrant operations. Here that is the circuit, that is chopper 1 CH1, that is chopper 2 CH2. Here this is a diode D1, here this is a diode D2. That means now see that if CH1 and CH2 is in operating mode, that means conducting mode, what will be the directions of current? So the current is flowing from source side. This is CH1 is in operating mode, that means this is going to be closed. Then that is the current going through load, and that CH2 is again in operated mode. That means the current path will be like that. So we can say that when here CH1 and CH2 is in operating mode, then the V0, that means the voltage across the load, will be equal to Vs, and the current directions is, that is from source to load side. Now when we are considering that CH1 and CH2 will be in non-operating mode, that means that is in non-conducting mode, then what will happen? Then say that, so this is in non-conducting mode, that means no current can come through this part. This is in non-conducting mode, but these and these are in conducting mode. That means now the directions of the polarity of the voltage will be reversed. Now the current is flowing through this part. That means the polarity now going to be reversed, because this is non-operating mode, this is non-operating mode, but these two are conducting mode. So what will happen? The polarity will be reversed. We can take that V0 equal to minus Vs. So when D1 and D2 in conducting mode. So D1 and D2 in conducting mode means the voltage polarity is going to be reversed. So V0 equal to minus Vs. That means we get that the voltage is in two quadrant. When CH1, CH2 is in operating mode, the voltage that is considering as a positive voltage, and when the D1 and D2 in conducting mode, then this voltage polarity is going to be reversed. But if we considering about current, here you can say that, you can see that the current is going through load, that is in same directions for the both side. When CH1 and CH2 on, the current is flowing through load from this side to this side, and when D1 D2 is on, then again current is flowing through load this side to this side. That means the current directions is in both case, that is in same. So the current is considering as a positive current, but the voltage here, the polarity will be reversed for the operations. So this is considering about two quadrant chopper or type B chopper. Here the first quadrant is positive quadrant where the voltage is positive, and in the fourth quadrant the voltage is negative, then it is called as the fourth quadrant operations. Now what is alpha? Here we can see the three conditions: alpha greater than 0.5, alpha equal to 0.5, and alpha less than 0.5. That means alpha is, we know that it is duty cycle. That means the percentage of conductions. Suppose if we are considering about this, suppose this is a voltage waveform. Here you can say that this is T on, that means the chopper circuit on, and this is T off, that means chopper is in non-conducting mode. Here from the diagram you can see that the T on, that means the on time period is greater than off time period. The on time period is greater than off time period. That means the duty cycle obviously greater than 0.5, because we know that alpha equal to T on by T. So if T means the total time period, that T equal to, we know that T on plus T off. So if T on is greater than 50%, that means alpha greater than 50%, then it is the average output voltage can be considered as positive. But if the T on is less than T off, that means the non-conducting time is more than the conducting time. Suppose this is T on, this is T on, that means this is T off, and this is T on. That means the T on time is much less than the T off time. That means the non-conducting time is much more than the conducting time of chopper. There we can say that the value of alpha, that means duty cycle, obviously will be less than 50%. So the average output voltage through the load, we can consider it as a negative. So this is the conditions. Now the last operations, that is type E chopper or fourth quadrant chopper. Now in the fourth quadrant chopper, there are 4 chopper and 4 diodes, CH1, CH2, CH3, CH4, D1, D2, D3 and D4. Here this is a voltage source, EMF E, that is the load in the inductance L. Now this is the source side. Suppose we are considering about the first quadrant. So what will happen? In first quadrant, the CH4 chopper is on and CH1 is operated, other is in non-operating mode. So when CH1 is going to be operated, that means this is going to close, this part is going to close, that means current is flowing from source side through this CH1, through this, through, and this is CH4 is also is on, that means the current is flowing through this part. So this is the directions when we are considering CH1 is in operated conditions and CH4 is on. So this is the first quadrant. We considered it as a first quadrant because here the V0 equal to Vs, that means the total source voltage is fed to the load from these directions, and this is called as first quadrant operation. Now suppose CH1 is in operating mode and after the conduction time period over, the CH1 is going to be non-conducting mode. So when CH1 is going to be non-conducting mode, then what will happen? See, this is in non-conducting mode, that means these voltages cannot go through the load, that means this cannot be put through the load, that means the current is free wheel through this part, through load, through CH4 and D2. So that means the operations, this is called as first quadrant operations because here the V0 and I0 value is obviously treated like a positive value, because when CH1 is operating condition, then the source voltage is directly going to feed the load. So that means V0 is positive, V0 equal to Vs, and the current is going from source to the load side. So I0 is obviously treated like positive, and when the CH1 is in non-operating mode, the current is freewheeling through this part, that is CH4 and D2 and L. So the current value is again in the same directions like the previous. So this is called as positive directions of current V0 and I0, and it is first quadrant operations. Now when we are considering the second quadrant operation, for second quadrant operation all the other parts are in non-operating mode, only CH2 is in operating mode. Now if CH2 is in operating mode, then what will happen? See, this switch is going to be in on conditions. Now a reverse current is going to flow through the circuits. So what will be the directions of that? That means this is the L, this is the voltage source E, this is diode D4 and this is CH2. Now this CH2 is in operating conditions and the current is going to flow through L, E, CH2 and D4, that is in negative directions. Remember, in the last circuit we considering the current is flowing through CH1 to this side. So if this is positive directions, now when CH2 is on, so the source voltage cannot feed the load. So from this EMF source a negative current is flowing through CH2 and D4. So this is the negative current. And the L inductor actually going to store the energy. Now when the CH2, the chopper 2 is going to be in non-operating mode, then what will happen? Then see, this is now in non-conducting mode. That means the current is cannot going through this part. So the current is going through D4, E, L, D1 to the source, because this is in non-operating mode. Source voltage cannot feed the load. So what will happen? The energy of L, that is going to be dissipated. So that is the current is going through this part, D4, E, L, D1 and source. So that means the directions of current going to be reversed from load side to source side. And we already know that when the current is flowing through load side to source side, then it can be considering as a step up chopper. So this is the second quadrant operations of type E chopper, where we can see that the average voltage value is positive, but the current value, the current directions is going to be reversed. That is going to source load side to source side. So it is called second quadrant operations. That means V0 is positive but I0 is negative. Now we have to consider about third quadrant operation. Here CH1 and CH4 is off, CH1 and CH4 is off, CH2 is on and CH3 that is in operating mode. So what will happen? See, CH2 is on and CH3 is in operating mode. So what will happen? Here the source voltage actually going to feed the load in different directions. Here the source voltage going to feed the load in the reverse direction. That means the polarity of the voltage is going to be reversed, because CH2 is in on conditions and CH3 that is in operated mode, and another all the parameters, all the circuits parameters is now in non-conducting mode. So what will happen? Now the current from the source side is going through the load in these directions. So that means the load is fed from the source, but the source voltage polarity is going to be reversed. So when the source voltage polarity is going to be reversed, then we can say that that is a third quadrant operations. Here the V0 and I0 obviously that is in negative directions, that means that is in reverse directions than the other quadrants. So the V0 I0 is negative, so this is called third quadrant operations of type E chopper. Now the last quadrant, that means the fourth quadrant operations of type E chopper. When we are considering the fourth quadrant operations, then what will happen? Only the CH4 is in on conditions, that means in operated conditions, and others all are in non-conducting mode. So now when we are considering only CH4 is in operating conditions, then what will happen? Then the current that is actually flowing through this part, only CH4 is in operating condition. That means that is the